is used to wash many things like dish or clothing, and in every case it's acting the same way. It works at something called the surfactant, which emulates oils and allow them to be carried by water historically. Soap was made by using a combination of rainwater, animal fats, or vegetable oil and aged over thousands of years. Process was slowly refined, and it was eventually discovered that the major ingredient in the ash was from base for a very long time. Also was solid soap, and it wasn't until 1865 when a man named William Sharper patented a liquid version. From then or more and more liquid type soap were developed, and now we have a huge variety of different options. The invention of proper liquid form of soap was actually a pretty big deal because it makes it a lot easier to clean things like floor and clothing. Soap is derived from the triglyceride, which are the fat strong molecules used by almost all plants. Animal fats and vegetable oil are almost just pure triglyceride. There are two major parts of the triglyceride molecule: the glycerol backbone and the fatty acid tails, and ester bone connect to the tails to the backbone.
Two objectives for these experiments are this one and this one.
The apparatus and chemical was used in these experiments are:
firstly, measure 150 ml of used cooking oil and coconut oil and filter the oil to remove any food particles using a filter cloth. Added 50 grams of sodium hydroxide and mix it with 100 ml of water. And then, we measure the temperature and allow it to cool down to 60 degrees Celsius. After cooling, we added sodium hydroxide to the oil and mixed it with the constant stirring for 30 minutes until it reached a thick and creamy consistency. Lastly, we added food coloring for 80 ml of water and continued to stirring the mixture. Pour the soap solution into silicone mold and rest it for 24 to 48 hours.
After the mixing process of a book soap from the appliance oil, the texture of the soup is quite viscous and thick due to the mixing process resulting in a pink color. After a few hours left at the room temperatures, the salts form according to the prepared moles. The step to calculate the pH level are used to determine of the level of the qualities of the pH. The result in 13th level pH. After a few days living at the temperature room, homemade soaps textures can vary based on the ingredients, but often they are smooth and creamy feel. The consistencies depend on a factor like the oil used and coconut oil. Some may be more moisturizing, creating a luxurious, silky textures, while others might firmer, exfoliating feel if an additive like oatmeal or herb are included. Overall, the texture is a very delightful blend of nourishing and cleansing elements.
What is the reaction involved in preparation of soap? The reaction involves the ester bonds in the triglyceride breaking down and the sodium ions from the sodium hydroxide forming a salt with a fatty acid released during hydrolysis. The resulting product is soap, which is essentially the sodium salts of the fatty acid found in the used oil, and the glycerol is also produced as a byproduct. It's important to note that when making soap from used cooking oil, it's crucial to ensure that the oil is properly purified and free from impurities, as a contaminants or food residues in the used oil can affect the quality of the soap produced. Additionally, safety precautions should be taken when working with sodium hydroxide, as it is a caustic substance and can be harmful if mishandled. What is the pH of the soap before and after drying? The pH of soap is typically alkaline, and the specific pH value can vary depending on the formulation and ingredient used. The pH of the soap in this experiment is 12 before drying and 13 after drying. These pH values are quite high on the alkaline side due to the use of now in the production of this soap, with the pH after drying being even more alkaline than the initial pH. This increase in pH after drying can be due to several factors, including the concentration of alkaline used in the soap making process, the presence of impurities, or variation in the chemical composition of the used oil. While soap is typically alkaline, it's important to note that extremely high pH values can be harsh on the skin and may not be suitable for personal use. Soap formulation are often adjusted to achieve a milder pH for skincare purpose, typically around 9 to 10. If the soap pH is 13, it may be too harsh for regular skin use and need consider adjusting the formulation to achieve a lower and milder pH.
Next, the answer for this question are: coconut oil is a very popular ingredient in soap making due to its benefit to skin. Some of the functions are moisturizing, is where the coconut oil creates so protective moisturization on the skin as a full antioxidant and is compared of healthy saturated fats and vitamin like vitamin E, amino acid, lauric acid, and capillary acid. Point number 2 is hardening, which is this sample is a solid in a room temperature and it can be harnessed to a soup bar like this. This aspect of coconut oil is extremely valuable, especially when creating soap with other oil that alone will produce of softer product. And the other function are lathering, antibacterial, antifungal, and antiviral properties. Overall, this coconut oil is an effective ingredient of soap making. The answer of this last question are the role of sodium hydroxide, or as known as NaOH, in soap making is to saponify the oils and fat used in the recipe. Saponification is the process that converting oil and fat into a soap by creating them with an alkali such as NaOH. When NaOH is added to the oil and fat, it breaks down the triglycerides into a fatty acid and glycerol. The fatty acid then react to the NaOH to form soap molecules and glycerol. This chemical reaction is called as saponification. The amount of the NaOH used in the soap making is critical, as too little will result in a greasy soap, while too much will result in a hard soap that can irritate the skin. Therefore, this is very important to measure the NaOH accurately and to follow a recipe that has been tested and proven to work. In summary, NaOH play a crucial role in soap making by saponifying the oil and fats used in the recipe, resulting the formation of soap molecule and glycerol. That's all for the question part.
In conclusion, soap production from used cooking oil is an environmentally responsible and cost-effective approach to waste reduction and sustainable product development. The objective experiment has been achieved in producing soap using this used cooking oil to evaluate the quality and cleaning ability. In addition, in the production of soap can evaluate the feasibility of converting using cooking oil into environmental friendly soap. By recycling used oil into soap can reduce the environmental impact of disposal. This process can contribute to the reduction of pollution and promote cleaner and more sustainable practice in the community. Finally, the use of the soap produced is using NaOH, where the use of the soap can be used after a month due to the high alkali content.